Agenda for today. I'll be covering a quick overview of AWS and resilience and how PwC, one of our resilience competency partners, defines the journey to build a resilience for your critical applications. My name is Diego Dalmolin. I'm Principal Solutions Architect for the Resilience Competency in AWS. I'm the technical lead for the Resilience Competency. And along with me today, I have Ross Chernick, Director of Cloud Transformation on PwC, AWS Ambassador, and also the person to go to when it comes to building resilience in AWS. Let's get started. I'd like to first start with this very famous quote from Amazon CTO Werner Vogels. Everything fails all the time. Have you seen this before? Is this the first time you've seen this? Well, I'll share my takeaway on this. Hardware can fail, software can have bugs, networks can experience outages. That happens all the time. I mean, it's just a matter of when it's going to happen. So it's not only about this type of failures. You also have to include other type of failures, for example, ransomware attacks, intentional, unintentional data wipes, or by the end of the day, applications are failing and are also unavailable. You cannot design for a world that everything is perfect and just working all the time. Instead, you need to architect your applications in order to be resilient and to be able to withstand any kind of situations that it's facing in these types of failures. Just because it never happened, that doesn't mean that you should not be prepared for any kind of these incidents. We like to say, like, luck is not a resilience strategy. So you have to be prepared for that. Why should you care about resilience? Well, according to these IDC studies from a few years ago, unplanned system downtime for the Fortune 1000 companies in the US costs about $1.2 to $1.5 billion per year. That's not just the financial cost, because there's the brand cost. Your end users are expecting your systems to be working. When they're not working, causes frustrations. If it's not performing as expected, your customers ended up being frustrated. So it can have a negative effect in your brand. And even the perception of your brand. In more extreme situations like a ransomware attack, you can even if you can recover from the attack, it may take a few days or hours or days or weeks. So you should factor in the cost and financial and brand it may take in this kind of situation. So with more resilient systems, organizations are able to offer to their end users a more consistent experience, support customer stickiness, and increase revenue. So why are we talking a lot about resilience in the past years? Well, if we think about internet today in the modern era, customers' expectations is everything should be always on, everything should be always available, and everybody has to be pushed towards that direction. Your customers are expecting you to be available and resilient. What is resilience? And you heard from me talking a lot about that. In AWS terms, resilience refers to the ability of a workload or application to be able to quickly respond and to recover from failure. So a workload may consist of a simple application, a monolith running on a single virtual machine or EC2, but it also could be a super complex application composed by microservices, APIs talking to each other, connecting back to your on-prem environment. So that's an application. After all, you have to think about the user journey on what exactly my customers are expecting to access through this journey in order to call that my application is online and available. In order to build resilient applications in AWS, we have these three pillars. It's a mental model. First, the application needs to be highly available. Can withstand common errors, for example, a failed hard drive. That should not impact the capabilities of the application to be working. The second one is the application needs to be recoverable. I mean, you need to protect this application and recover that in case of a more severe type of incident, a catastrophic type of incident. Flood in the data center, a ransomware attack, somebody deleted something. You have to have a recoverability portion of that. Supporting all of this is the sense of continuous resilience. Operational guardrails, your CI/CD pipelines, standard operation procedures. Your operation teams needs to feel comfortable in doing the right things. Observability, for example, it's big when it comes to resilience. You need to detect incidents before your customers detect the incident. So this is the mental model from an AWS point of view. Whose responsibility it is of being resilient? I thought that just by running in the cloud, I would already be resilient. Yes, that's partially true. In AWS, we have something that's called shared responsibility model for resilience. AWS will be responsible of the resilience of the cloud. So we take care of and the customers will be responsible of the resilience in the cloud. So AWS take care of the underlying infrastructure, virtualization, networking, highly available, the way we construct our data centers with isolation between regions, with multiple availability zones within the region. So that's what we do for customers in order to build a resilient application. Now, it's the customer responsibility to build their part as well. How often do you need backups? What's your RPOs and RTOs? Have you tested your disaster recovery in the past few days? Are you observing, monitoring the right things? Does your operation teams know exactly what they need to do in case of an emergency? So these are things that AWS can provide guidance along with AWS partners as well, on what the customer should be doing to achieve that resilience in the cloud. Now, everybody's on the same page. We know what resilience means. We know the shared responsibility model, the 3 pillars, high availability, the disaster recovery, and operations foundation. And I would like to say that resilience is not a one-and-done type of job. It's something that requires constant iteration, constant learnings. Something is going to fail. You're going to learn from that fail. You're going to improve your architecture, your operations for that. And I would say it's a journey. So Ross now will share a little bit more insights on what a journey to resilience looks like.
Thanks, Diego. So, achieving a sustainable AWS organization is a continuous journey that requires evaluation, planning, and execution. We follow this framework now with several clients and have found that our guiding principles and roadmap can help others achieve success. PwC's Resiliency Journey Framework provides a structured approach to adopting resiliency by evaluating the resilience capabilities, design resilient cloud architecture, build core infrastructure across AWS regions, enable resilient applications, and continuously test resiliency. For each area of this framework, we'll walk through a number of point of views and design considerations, but by following the framework, organizations can enhance their resiliency posture, mitigate risk, and ensure operational continuity. To evaluate your organization's resiliency capabilities, we developed a holistic framework to assess people, process, and technology. The framework will help organizations understand their readiness for effectively responding and recovering from unexpected incidents. Often our clients view disaster recovery as purely a technology function, but we all know during a disaster it's a combination of multiple teams, cybersecurity, technology, and the business all working together to respond to an incident. These capabilities highlighted here are the foundational building blocks for enabling future state resiliency capabilities. So prior to the last 24 months, our clients have been focused on building applications within a single region and only across multiple AZs. But with the enhanced regulations coming out around resiliency, an increased number of applications running in production, and a greater number of regional outages in AWS have focused our clients on building and designing multiple applications across regions. So prior to implementing these workloads across regions, there are a number of design considerations that should be looked at, whether you do multi-region or multi-AZ. And so for those critical applications, it's essential for organizations to evaluate your business impact, your risk, and the cost of your disaster recovery strategies, define your RTO and RPO for designing the required DR strategy, as these will influence the cost to run your apps, and enable automated processes and tools to support the periodic failover to meet your RTO and RPO. So for organizations that require multi-region configuration and plan to operate out of a secondary region, it's critical that your secondary environment has a similar look and feel as your primary. This involves setting up all of your core networking, your identity, your security, and all of your DevOps tools to support the pre-deployment of your applications in the secondary region. Deploying new workloads in a new region is now giving organizations an opportunity to revisit some of those legacy landing zones, adopt new control tower features, enhance their security policies, and apply more modern security policies. We have now seen firsthand that secondary regions can just as easily be attacked as the primary region, so similar tools should be adopted. So for most companies, responding to a disaster or an incident can be very difficult with multiple teams involved, all trying to figure out how to remediate or redeploy an application that probably hasn't been launched in months or even years. It's even tougher when the when the application owner no longer works for the company, there's little to no documentation that exists, and the dependencies aren't well known. For organizations, though, with a heightened focus on resiliency, their goal is to decrease our RTO, reduce the recovery activities during a disaster, and this is what we call our pre-recovery steps. Pre-recovery includes setting up all of the foundational environment, your security, your networking, your identity, your CI/CD tools, and configuring the continuous replication. And then all that's left is during the recovery phase is the application data is validated, the app is redeployed, and then tested. So here's an example of an EC2 instance backed by Aurora, and the configuration of the global database is configured as part of pre-recovery. So it's all that's left is during disaster, the instance is turned on and is scaled up. But performing these tasks ahead of time can increase your RPO, reduce the RTO. But in the spirit of automation, we still find that our clients, even our most sophisticated ones, are going through this recovery process in a siloed and manual approach. So we developed PwC's DR Orchestrator. The DR Orchestrator was born based on the necessity of one of our clients. Their future state design required a multi-region resiliency with aggressive RPOs and RTOs, and we were encouraged to develop an automated solution because their DR plans were a manual exercise that required a dedicated team to guarantee the failover and failback. This procedure in the past was very time-consuming, unpredictable, had a high RTO, and required the reliance of human intervention. The DR Orchestrator, it automates the disaster recovery of your critical AWS services to a healthy region in the event of a disaster, and also allows frequent DR testing with minimum developer impact. Some of the key highlights and benefits of the DR Orchestrator: it can reduce your RTO from multiple weeks down to just minutes, reduction in your overhead from operating and maintaining failover and failback operations down to 50%, and it allows your development teams to focus on enabling features in your application rather than focusing on resiliency, which could lead to a reduction in months to weeks. So here's an overview, a very detailed overview of the DR Orchestrator, but at a high level, the solution automates the failover and failback of applications using AWS step functions and Lambda by tapping into the existing CI/CD pipelines to scale up the infrastructure and apps in the event of a disaster. We've implemented this at several clients and have found that with all the different types of tech stacks applications have and the varying DR strategies, the feedback is that it's customizable, it's scalable. And as you can see here in step 6, it's our op modules. We've developed op modules for every application stack for each DR pattern, whether it's backup restore, pilot light, or warm standby, that we can use to configure applications disaster recovery. This combined with the ability to use CloudWatch and CloudTrail to monitor and log how long it took for your failover and failback jobs. And this feature is great for our regulatory clients because they can use this as evidence to respond to the regulators. So this is just a high-level view of our solution and on our resiliency approach. We thank everyone for joining, and if anybody has any questions, please let us know. And thanks, Diego, for your pitch as well.